Hi guys, I'm John Hamanuk, and welcome to This Week in Storm Chasing. Today is Sunday, February 25th. I did not expect to be doing a This Week in Storm Chasing video this early in the season, but here we are. Active conditions, as we expected, would develop in late February and early March, and here we are talking about severe weather over the next couple of days. There are two regions that we're going to focus on in this video. As you can see right in front of you, we have one highlighted over the Ohio Valley in Illinois and parts of Indiana, and another one back across the plains, which is going to get everyone's eye, I'm sure. We'll get to that eventually. Let's look at the Storm Prediction Center's Day 3 convective outlook for Tuesday, February 27th. And obviously, we have a slight risk area across a lot of the Ohio Valley from the southeastern Missouri into Illinois, Indiana, and even including parts of southern Michigan with this threat, and that marginal risk surrounding it in green extending a little bit further out both to the south and northeast. So a fairly broad severe weather risk area. From a storm chasing perspective, you'll notice that I've highlighted a much smaller region, and that's the area that we're going to focus on for the potential for supercells and maybe even tornadoes with this event. Obviously, I want to note this is a storm chasing discussion. Refer back to the Storm Prediction Center maps if you're looking for actual guidance on how these storms might affect your area, because those are the official forecasts for that. This is just a storm chasing map and a storm chasing focus region. So let's get into the setup. Here we are at 500 millibars. So we're looking just at 500 millibar heights and winds, and this is valid 18Z on Tuesday, which is the threat day. And you might be looking at this map and saying, I don't know where the threat is. And you're not really wrong, because it's a very unique little setup that we're dealing with here. So the focus area here obviously is across the Ohio Valley, and we have southwesterly flow at 500 millibars, enhancing through the evening a bit. This is the morning, and then as we get into the afternoon and evening, we see that southwesterly flow really increase into the evening and overnight. And then overnight into Wednesday morning, the jet really picks up. So we have a southwesterly flow at 500 millibars, but no real deep trough, amplified trough, not really a huge system here in terms of amplitude. And if we go and look at the operational runs, this is the European, just see that same general idea, right? We have this 500 millibar flow, southwesterly flow coming through during the afternoon and evening, but this system just tends to look a little progressive right off the bat. Here's a lower level jet getting down to 850 millibars. And again, really, you start to see it ramp up here in the afternoon and evening southwesterly, but there's really no crazy backing to the low-level jet, and it also remains fairly progressive, right? It's just barely kissing the area that we're watching here during Tuesday afternoon and evening. That low-level jet sort of scoots on out fairly quickly, and as we mentioned, the system just feels kind of progressive at this moment when looking at these initial maps. Here's the European ensemble. I like to use the ensembles early on here in this process. Here's the European ensemble. Probability of CAPE over 500 joules per kilogram. And you can see it increase during the afternoon hours. You kind of get this like tucked in look here with some CAPE pulling up near what I would assume is a surface low, right? This is Tuesday afternoon and evening. This is valid 0Z Wednesday, so Tuesday evening. And you can see those higher probabilities are kind of tucked up right in here near where there could be the development of a surface low in western Illinois. And we'll get into why that's important. But sort of moderate probabilities of over 500 joules per kilogram of CAPE, which brings us to the next point of conversation, which is that there's not a ton of moisture or instability with this system. It's fairly limited. I want to show you guys what it's going to look like the night before and the day before. And obviously, this is not favorable moisture. It's early in the season for this, and we need to advect a lot of this moisture northward. So here it comes, though. Monday afternoon and evening, you see this northward advection of moisture. And that continues through the day on Tuesday. So models are advecting deeper moisture up as the event is unfolding. And then you start to see a little bit more of that moisture kind of pooling in Illinois and Indiana. Now, what we see initially here, and I want to point out this area here in Missouri and Illinois and zoom into that a little bit more. What we are looking at here is effectively a dry line. This is the cold front way back here. You see this sort of northwest to southeast moving front. That's the cold front. But what we have here, this sharp gradient between 60s and 40s, is sort of an effective dry line that's developing on models here. It's a very small window, right? Here's your dry line set up here, curling up into western Illinois with some better moisture sitting in Illinois. And obviously your surface low is probably right around here. Your cold front is right there, just knocking on the door as this event unfolds. This is valid 5 o'clock Tuesday. So your storms are probably getting ready to go, and then that front is just bearing down and eventually takes over the dry line. But we do definitely have a small window here with basically an effective dry line in Illinois. The moisture, though, again, just looking at this, we're talking mid 50s to upper 50s here in the warm sector, the area that we're focused on. So we need to see how this moisture performs in the next 12 to 24 hours to get an idea as to how this might actually unfold. So a couple takeaways right now: a progressive looking system. We do, though, have sort of an effective dry line pulling up into western Illinois, and we have just-in-time, barely good enough moisture in a very tight window for potentially some severe storms. Now, looking at that surface low, it's pretty much right where we would expect it to be. This is valid at 6 o'clock p.m. on Tuesday. But I want to show you guys a trend that's ongoing right now. And I'm going to back this up to yesterday's European run. So your surface low was stronger and further west. It was in western Illinois, almost on the Iowa border. And then each run since then has sort of pushed it further south and east, especially today's run. So here's a comparison with yesterday's runs and today's run. So notice how everything is just a little flatter. And that tightens that window even more. It means that the front is bearing down and everything is just even tighter, and things are sort of veered out again, limiting the window for potential severe storms, supercells, and tornadoes here. Looking at a couple of forecast soundings in the warm sector, this is the NAM model that we're going to use for this. And this is the furthest west model, so this is kind of the prime time scenario here. We do see a couple of things. We have sufficient moisture on the NAM. It's a little shallow, but it's generally getting the job done. Temperatures are a little cool. They're in the upper 60s, and the dew points are near 60. But photographs are favorable enough. You have some turning there in the lower levels, and a decent enough photograph that could produce supercells and maybe even tornadoes, especially with this level of 3 Cape being modeled, and that potential vorticity. So I think overall, when we're looking at this sounding, it's okay on the NAM. You'll notice the backing of the low-level winds, and that's something that I want to talk about here. This is a south-southeasterly low-level wind barb right here, and you can see the turning that occurs as you drop further lower in this sounding. If we go back to this European run, earlier model runs from the European had the surface low in this area, and this is where the NAM has it right now. And what that does is it helps to back the winds around the low, right? Because you have a deeper surface cyclone, your low pressure is ramping up a little faster. And so your surface winds are going to tuck in and curl in towards that surface low. When you have a weaker reflection like we see on today's run, the surface winds tend to veer out. So they'll stay kind of south or southwesterly, and that decreases the amount of that low-level wind shear that you get if your wind barb is this way instead of this way. And so that's a major thing to watch with this event. If we look at where the European model has these dew points sort of curling in, this is the region where you'd want to watch for the potential for those surface winds to back a little more and enhance the potential for supercells or tornadoes with this event. And I think that needs to be watched really closely. Does that surface low wrap up a little and help back the low-level jet and those surface winds a little, or does it remain more progressive? Because if it's more progressive, this event probably goes off without much opportunity for quality storm chasing. Here's another example of how that might happen. This is the latest HRRR model. And just looking at the surface low valid at 0Z Wednesday, it's really broad, right? You have sort of this broad look. Your surface low is here. It's just very broad and progressive, and you don't get any southerly surface winds. Look at all of them are more southwesterly here. Your moisture kind of shoots up this way, away from the surface low, and you get sort of southwesterly flow instead. And that would be how this event kind of goes off without anything substantial. Looking at the NAM, the surface low is a little stronger and further west, and you're able to back those surface winds a little more and create a potential for some sort of supercell and maybe a localized tornado threat. And to that point, here's how the NAM says things could evolve. This is valid at 0Z Wednesday, and right near the surface low, you get convection developing. A couple of these storms are rotating right near where that surface low would be, and if we look at, again, the dew points, they're pooling up right near that low, and those backed surface winds are clearly visible. So this is how this event works and produces something that's notable. It's when the surface low is a little stronger and more organized, and everything sort of curls in a little more, including the moisture, the surface winds, and the low-level jet back a little more and support that potential for convection that could produce not only good visual supercells here right near the surface low, but also the potential locally for some localized tornado potential as well in Illinois as this event evolves. Otherwise, if the more progressive models are correct, this likely ends up a fairly non-impactful system when we look back on it overall. So again, just going back to the overall outlook for this, our idea right now is that this has the potential to be a locally decent storm chase in Illinois. I think that the progressive possibilities here probably preclude this being a more substantial event. It needs to be watched as we go through the next couple of days. I'm not overly keen on this as a chasing event, but I do think that if you're in the area or you're within driving distance, it's probably worth taking a look, because if these supercells do go and the surface flow does tighten up, it could be a good show there for a couple of hours. All right, let's totally change gears now and shift our focus into the North Pacific Ocean. And I want to show you guys what's going on next week and weekend and why we're paying attention to this event at such a long lead time. The first thing that we see when we look at this pattern is a ridge in the North Pacific, centered right underneath the Aleutian Islands. Experienced sort of older veteran storm chasers will know that these ridges appearing often preclude the potential for a western U.S. trough, and this will be no different. Just sort of this Aleutian ridging developing here as we move into the middle of next week, the early and middle part of next week. But what this is really part of is something we call a Pacific jet retraction. And so what we see as we move into the early and then middle part of next week is a very wavy Pacific jet. And the best way to think about this is that you've probably heard this winter all about these really long, extended Pacific jet streams. That's when you have one long jet going essentially from Eastern Asia into the Central and Eastern Pacific. And that tends to just flood the country with warm air and lead to very active conditions. But for storm chasing, the magic happens when the jet retracts. So when all that momentum stops, what happens is sort of like a rubber band or a really tight rope that you suddenly flick, and all of a sudden you get these waves to come out. And these wave packets bring troughing into the western United States at times, especially when you have a pattern like this in the North Pacific, because your waves are guided this way underneath, east of the ridge and down into the western United States. And so that's what we see here. This wave that you see right here during the middle of the week that comes over the top of that ridge. This is our eventual system that we're going to be watching, and watch how it just amplifies down into the western United States. And that's the magic that happens with this jet retraction and helps lead to this potential event. So when we look at what the models are showing, this is the latest European ensemble. And obviously the first thing that sticks out is this behemoth of a trough coming into the western United States. There's a subtropical jet involved here as well. You see this jet stream underneath it sort of pushing into parts of Mexico. And we have this trough digging into the western United States. Now, there's a couple of intricacies that we could get into. For instance, there seems to be some signal for troughing in the eastern United States, and the subtropical jet is sort of pointed at the Gulf, which makes you wonder about how that will affect the ambient environment ahead of this trough. But if we keep it simple and we look at where we are right now, this is a deep mid and upper level trough dropping into the western United States, and you can see the southwesterly flow beginning to overspread the Rockies. Now, looking at what the models show specifically that has my interest, we have a very broad signal for a low pressure system in the Rockies, and we have a high pressure in the east. So you're going to have return flow coming out of the Gulf of Mexico with a high pressure like this and your low pressure developing here. So early signals here on the ensembles are that we're going to have the potential for an anomalous environment as this trough comes in. And if we look at the ensemble dew points, no surprise, it does in fact look quite anomalous. This is really impressive moisture for early March. The ensemble means, especially the upper bound, showing the potential for upper 50s in parts of Oklahoma and mid 50s into parts of central and eastern Kansas as this wave comes in. That's really notable, with 60s kind of closing in on the Red River here. This is an impressively moist signal and a very broad looking warm sector across all of the plains and the Midwest and even up into parts of the Ohio Valley here. This is a broad warm sector, which is not surprising given what we see here with this high pressure and the deep low and big trough coming into the western United States. So here's what the ensembles eventually do. This is a European ensemble. They bring this trough in on Sunday. So this is Sunday afternoon and evening. Big time southwesterly flow coming across a lot of the plain states. And when we think back to what we have in place here with this moisture and the signal for some sort of dry line situation here in the plains, this trough becomes even more impressive. Obviously, this is a very substantial signal. Even though it is 180 hours out, it does get your attention, especially given the fact that we know that there's some synoptic support for this trough to actually happen. Here's a signal for potential for CAPE over 500 joules per kilogram. Obviously, this is very impressive and shows you anomalous nature of the moisture that's in place here with this really large area of potential for notable instability, especially for early March. So anywhere really from across the entire plains on an axis here from the Dakotas down into Nebraska, Kansas, Oklahoma, Texas. This is the potential for that instability axis to develop as we move closer to this event. This is the operational Euro, and I just want to show you this because this is the operational and this is the ensemble. So we have pretty strong agreement between the two here, but the intricacies of how this plays out are going to be critically important. This, for example, is the GFS model, the GFS ensemble, I should say. And here's the difference between the GFS ensemble and the European ensemble. And this makes a huge difference on how this event plays out. The GFS is slower and ends up a bit further south, sort of some phasing going on with the subtropical jet, so you don't get as much southwesterly flow into the plains when you compare it to the European ensemble. These two models lead to very different outcomes when it comes to this event. That being said, when we look at this overall and we look at the ensemble signal for not only broad southwesterly flow and a big trough, we do see the trough exists on multiple ensembles, including the GFS, the European, and the Canadian. And we also see this signal for moisture, anomalous moisture. Obviously, it is time to start paying attention. It's a week away. We're not going to get into the details or the intricacies, and we know that the way that this plays out could vary significantly from what we see right now on models. But given the synoptic signal for anomalous moisture and the potential for this southwesterly flow to eject out into the plains, we were comfortable noting this as a potential to have some storm chasing as we move into next weekend. Again, right now, it looks like this would be a Sunday event. That's when this wave comes out across the plains. And in addition to a big southwesterly flow at 500 millibars, we also have a signal for a very impressive low-level jet, a big deep southerly low-level jet coming out of the Gulf, and that helps to bring in all this moisture and instability. So my word of caution for you with this trough, especially when we back up and look at this from a regional perspective, is that we are still several days away from having any idea as to the specifics of this. But when we look at the synoptics and the way that this looks to play out across the hemisphere, the potential does exist for this trough to come out and to produce an environment that would be conducive to early season storm chasing on the plains as we move into that first weekend of March, specifically Sunday, March 3rd, where we are watching the potential for some chasing here in the plains. So we will keep a really close eye on that. Obviously, I'm going to be watching this event on Tuesday. I will be out there and seeing what happens in Illinois, and then we're going to look ahead to this event potentially, and I'll have updates throughout the week on how things look for this Sunday event that could potentially bring chasing to the plains in early March. Thanks so much for watching, guys. We are going to be back obviously next week with the second edition of This Week in Storm Chasing. For now, have a great Sunday evening, and I'll talk to you on Monday.